Hey guys, welcome to day 5 RDDs, the roots of Spark. RDD, also called Resilient Distributed Dataset. In last video on day 4, we have seen the Spark architecture where we have seen it has taken a leap over Hadoop, which was a traditional way of processing the big data. But how Spark manages all these things is the basic component is Resilient Distributed Dataset, a dataset which spans across the clusters, is capable of building itself, and that's why it's called resilient. Distributed across cluster is that's why it's called distributed. And a data set. When Spark first showed up on the scene, it solved the painful problem in Hadoop. Every step you have to write the data back to the disk. Spark's answer was creating a new set of data set or a new set of data type called RDD, resilient distributed data set. It kept the intermediate data in memory, survived the failure via something called lineage, and gave us a simple mental model for distributed computing, a big collection split across multiple machines with functions applied in parallel. So even though if we spend most of the time in data frames nowadays, RDDs are the base or RDDs are the structure that resides inside the data frames. Just few years back, like just we can even see in some of the legacy projects where we are still transforming into new versions of Spark, there is a huge amount of RDD code written. But just 2 years back, what Spark has done is they have created a wrapper over RDD called data frame, and slowly they are versioning the RDDs out. Even to an extent, I could say that after Spark 3.0, you cannot create RDDs, and they have gone to a next step this year is like on Databricks serverless, which was introduced last year but enhanced by Databricks and being told as a next direction of compute, which is Databricks serverless. RDDs are absolutely not allowed. So every exercise that used to run on a dedicated cluster is not going to run on RDDs. Then the question is, why are we even learning RDDs? The reason we are learning RDDs is because RDDs are the wrapper, RDDs are the base component on which data frame is built. So this Databricks is going towards more of a declarative. Nowadays, every organization is going towards declarative type of syntax. So data frames form a declarative syntax over RDD. They abstract. Let's try to understand this. They try to abstract the complexities of RDDs. Okay, so that's why even though you will spend most of your time in data frame today, understanding RDDs is like a trying to learn a manual transmission car before driving an automatic, so that you understand the engine, what is happening inside. That helps you to optimize lot of times. What is RDD intuitively? In this diagram, you can see RDD is distributed across multiple clusters. It's a resilient distributed data sets, and Spark session or Spark driver is from where this complete thing is managed. So let's say this is a Spark cluster where you have a driver and an executor at multiple places. So RDDs will exist in a fragmented way on executors, and driver are the place from where it is going to be driven. Let's understand some of the basic properties of RDDs. RDDs are immutable. So once they are created, they never changes. Every transformation produces a new RDD, and therefore if data frame is a wrapper over it, data frame is also the same. Partition or split into chunks across the cluster. They are split into multiple locations across the cluster. They are lazily evaluated. The reason they are lazily evaluated is they continuously prepare a plan. They don't execute it unless there is some action. What is transformation, what is action, we'll understand that. But in short, if I tell, transformation is something where results are not produced, and action is something where results are produced. So unless there is a action, Spark will keep on creating a plan, and only after there is an action, it will start producing the result. This you must understand if you are building the code. Okay. So if data frame is like a spreadsheet with the schema and an optimizer, RDD is like a raw distributed list, powerful but at a low level. So I'm just showcasing these codes. This code doesn't work on Databricks serverless, and therefore the free account which is provided by Databricks, it only has Databricks serverless. So all these codes doesn't work. I can show that to you, but the code, definitely let's walk through that. Your first RDD, creation, transformation, action. How RDDs are created? Spark session, there is a Spark session which is defined. We have understood in last video what is Spark session. Once the Spark session is created, we can derive the Spark context out of it, and once the Spark context is derived, you can create an RDD. So this is an RDD. Nums is an RDD. And once RDDs are created, or whatever is created out of Spark context will be an RDD. So let's say if you're reading even a text file, the text would be an RDD. We can perform different transformation lazily, which is like it is just squaring it up, and like mod deriving the mod to just separate the even numbers out, and words, uh, where you are just trying to split the complete sentence with the space. So these are transformation. As I mentioned, during transformation, no data is generated. It's lazily evaluated. So only plan is prepared. Okay, only plan is prepared. Once the action happens, like we are trying to collect, right? Collect is an action. We're trying to get the data. So that time the things will be evaluated. So sometime what happens is we are writing the code and we are just testing it out, and we say that okay, my code is absolutely fine because it is getting compiled, but the action doesn't happen until the collect is called. So sometime after collect is called, we start getting error, and then we feel surprised what is happening. So it's because of the lazy evaluation of Spark. Transformation are the building recipes that Databricks provide to work out on the data. That is map, filter, flat map, distinct, union, sample. And actions are like cook the recipe. Actions are the one which triggers the data processing, like collect, count, take, save, create table, like that. So we pair the RDD's key values pairs are present. So this is another example where a RDD is created out of like a pair of data. Okay, um, we can simply parallelize. We can simply parallelize it. What we are doing is we are just trying to split the data. So this is an array of strings, and what we are doing is we are just splitting it into a map, um, and then we are just reducing it by key. Reducing it by key would reduce it and try to calculate the number out of it, or and then it is simply going to sum the second part of it, and once it is summed up, it is going to collect. Why is reduce by key a big deal? It combines values before shuffling data across network, reducing traffic. Contrast this with group by key, which ships all the values first and then aggregates. So this, there is always a debate why we should use a reduce by key or group by key. So we should, so as you understood, like reduce by key combines before shuffling. So combining before shuffling is good, because after shuffling, if you try to combine, then shuffling is a very heavy operation, right? So we don't generally, we are always trying to avoid the shuffling. So this reduce by key slows the usually slower and riskier on memory. Okay, why is reduce by key a big deal? It combines the values before shuffling the data across the network, reducing the traffic. So reduce by key is good. Whereas on the other hand, contrast with the group by key, which shuffles the data first and then aggregates. So they always say that you should use reduce by key. But all these things nowadays, what has happened is, since RDDs are not there and data frame has come, Spark would internally take care of new optimizers which has come in Spark, like Tungsten, Catalyst optimizer is there. So all those things would internally, when you just create Spark.sql or when you write down the code, it is job of spark to convert it into right plan, and at that time it would always use whatever is rightly applicable to you. So let's say reduce by key, it seems that your operations are very much suitable for reduce by key, it would use reduce by key instead of group by key. So nowadays you don't need to care much about this, but you must understand the traditional setups, how they were done. Because in many of the projects what happens is you are in a project where you are trying to convert everything from legacy to new set of doing the things, right? So there definitely definitely understanding RDD operation is very important. So they are saying bad in many cases. We are even given one example. Bad in many cases is ship all values. So group by key would ship all values and then calculate, whereas reduce by key would combine early and then would ship it. Okay. So narrow versus wide transformation. So transformations, we just moment back we understood what are transformation action. Transformation is something which converts the data and produces new RDD, whereas actions are something which triggers the transformation. Correct. So in transformation also there are two types. One is narrow and one is wide. Narrow is something where each output partition read from exactly one input partition. This is a best case scenario. Like you are reading, your data is like very much proximate on the cluster, you are just reading it only from one place. For example, let's say you are trying to combine the customers who have bought an Apple iPhone, correct, and you have distributed the data in such a way that whenever you are trying to combine it, you are getting it right from a single cluster itself. Only in single partition the data is present. In that case, you don't have to go to multiple places and then get the data back to the driver and then combine it. So that will take time, right? So this is the case where we always wanted to narrow down the transformation. So these are called narrow transformation. And wide transformation are something in which uh, output partition depend on many input partition. Like whenever we are trying to pull the data, we have to pull it pull that data from multiple places because of joins and everything. A lot of shuffling has happened. The RDD is distributed in such a way that you have to go across each and every node and try to pull that data. The shuffle is always costly. So after shuffle, so the operations which cause lot of shuffles are called wide transformation, and operation which causes less shuffle are called narrow transformation. And we are always looking towards having a narrow transformation. Shuffle when jobs slow down, disk spin, and network usage spikes. So shuffles, always avoid shuffles. It is definitely not possible always, but then you should try to avoid it. RDDs make this explicit. Data frames try to optimize shuffle anyway. Data frame is a declarative or wrapper over RDD. So that planning is taken care already by something called Catalyst Optimizer. As I mentioned few minutes back, there is something called Catalyst Optimizer which has come. So internally with algorithms and with proven techniques, it would try to optimize it. So if you define a data frame, it would automatically try to optimize it. Whereas in RDD, you have to ensure that you put a right operation. Okay, so data frame is definitely an advancement over RDD. And there is something called AQE, advanced query or advanced query execution. So that also helps in reducing the shuffle. Okay, so partitions and performance is partitions, as I mentioned, is very important. Like how you partition your data plays a very important role, because if your data, because of your partition, if your data gets skewed, then let's say what is skewing the data. So sometimes what happen is, let's say you are trying to distribute the data across an RDD or across an RDD, and what happen is in one of the partition there are 100 rows, whereas in other partition there are like just one or two rows. So what would happen is the one or two rows operation would happen. So what would happen is, um, the smaller partitions would complete faster, whereas the partitions which are having hundreds of rows will take time. So it will overall slow down the job process, and what will happen is, until that one cluster is done, we cannot shut down the other ones, right? So what, eventually we will keep incurring the cost of others even though they are empty or absolutely idle, and this happens a lot of time. If the data is skewed, the processing would be skewed, and the complete cost structure of the job is wasted. So rule of thumb for fresher is too few partition, ideal CPUs, too many is an overhead. So if you try to just distribute it across, then it would create a lot of shuffling. You would have to take care of the skewness and all, and both the things always causes a problem. There is another example where you can use something called persist in RDDs. How persist help is, so RDDs, as I mentioned, are evaluating themselves lazily. So if you want something to be evaluated, or some operation that needs to run again and again, so for example you have to run some extreme complex operations multiple times in Databricks, then then it would be better to have a persisted data set or a persisted RDD uh, created. So there is some property called persist. It is available in data frame as well. So if you use this property, what happens is, because of the persist nature, the data would not be calculated again. Just giving an example, let's say you have already have a data set and you wanted to aggregate it on multiple parameters, and then also save those aggregated files. Then each time what would happen is, let's say you first of all you will read the file, and then then you will write a first step where you will aggregate it on one parameter and write it down, and then you will aggregate it on the second parameter, write it down. So if you have to do such operation, then it would be better to have that data frame as persisted, so that it doesn't recalculate itself again and again. Coming to understanding some of the practical examples, I tried each and everything, or rather those exercises which I have shown you in the video a few minutes back. I have tried them on Databricks serverless, but the fact is, we are doing all these exercises on the Databricks free version, which is available for everyone, absolutely free. So on that, there is only one type of compute available, and that is Databricks serverless. There is one serverless compute, and there is one SQL serverless warehouse compute. Okay, so with serverless compute, what Databricks has decided is, like, RDDs won't work. So none of the exercises which I have shown doesn't work on serverless. The reason why we have gone through those entire things is because data frames are just a wrapper over RDD. So internally, still everything functions the same. The concept still remains the same. So understanding them was absolutely essential, because in next video we are going to learn what is called the data frame. So in that data frame, definitely, uh, because it does internally, data frame does all these things magically. So you must understand, because sometimes there is a need that you have to take the control back into your hand, right? Like you are flying a long haul flight, right? And then somehow some or the other problem happened in your flight while landing. Then the pilot will not trust the autopilot, and he would take all the control absolutely in his own hands. You must have seen in movies, right, where he try to land everything manually. He will try to land the plane manually. So that situation comes many times, where we have absolutely different data set, real world scenarios are different, and then we have to take that control back, where we have lot of levers which are provided in the data frame to manage RDDs. So therefore understanding RDDs still very important, because they are not obsolete, but they are just being wrapped over by data frame. So having said that, I have tried everything, each thing and everything here, but the RDDs don't work, because Spark context itself, you will get such an error that directly accessing underlying Spark driver JVM is not allowed. Even Spark context accessing is not allowed. So that's the reality, that RDDs are not supported. The shift to serverless as Spark matured, Databricks introduced serverless compute, a fully managed auto-scaling multi-tenant environment. It doesn't it In serverless, Databricks abstract the Spark driver and Spark setup entirely. You don't manage JVM, cluster, Spark context, or executors. Everything is managed by Databricks, because that's a huge pain. So it saves almost 60% of the time if you're not managing this. So that is always positive. But as I mentioned, there will always be a situation where you would have to take the things in your hand, right? So those are the situation for which you must learn. If RDDs are not supported, I tried almost everything, nothing is none of the code was working. But then on the similar lines, if you wanted to create a data frame, it's definitely possible. So let's say I was trying to create a data frame with some values, uh, with like a kind of a list or something. I was able to create it, like where I would just square it. So data frame way of doing things are different. They are almost similar to Python pandas, but what are they, we'll learn in the next video. Okay, so thank you guys for listening into this RDDs. as I mentioned, absolutely essential. Data frames is something we'll learn next, and we'll take this forward. Thank you. Thanks for watching.